Hello, welcome to Chapter 1, Closure Questions in CCG. Question 128. Trace the figures in parts A and B onto your paper and perform the indicated transformations. Copy the figure from part C onto graph paper and perform the indicated transformation. Label each image with prime notation. So in part A, we want to rotate figure EFGHI 90 degrees clockwise about point Z. So I'll do the best. Obviously, I don't have the maybe the paper and the tracing paper to use this, but I'll do the best I can to show you kind of where it should be. So hopefully that gives you a pretty good idea of what it looks like. On part B, we want to reflect JKLMN over line T. And so that would look similar to what I have on there. And then on the next one, we're going to translate ABCD down 5 units and right 3 units. But first I need to graph it on the graph paper. And so we're going to take each point, go down 5 and 3 to the right. So start with point A, 1, 2, 3, 4, 5, and then 3 to the right. So that's A prime. B, down 5, 1, 2, 3, 4, 5, and 3 to the right. B prime. Now C, we're going to run out a little bit of room, so we'll just kind of guess here, but 1, 2, 3, 4, 5, and 3 to the right. 1, 2, we'll say it's right here. That's C prime. D, 1, 2, 3, 4, 5, 3 to the right as well. So something similar to, this. So hopefully I did an alright job on doing those transformations. Question 129. Assume that all angles in the diagram below are right angles and that all the measurements are in centimeters. Find the perimeter of the figure. So we want to add up all the sides. So we'll start here. We have 6 plus 8 plus 6 plus, there'll be another 8, and I'll show you. This side, and this. Those 3 things add up to 8. And then we can add 1 and 1 to give us the rest of the perimeter. So if we add all those up, we get a perimeter of 30 centimeters. Question 130. Estimate the measures of the angles below. Are there any that you know for sure? So for part A, we know for sure that this is 90 degrees because of the marking. On part B, if you kind of measure it up, you might use a protractor as well, but it looks like it's a little bit bigger than 90, so we'll go with approximately 100 degrees and use the symbol there. On C, we know that's 180 degrees. That's a straight angle. And then on D, we do know it's an acute angle, maybe approximately about 30 degrees. Question 131. Examine the angles in problem 130. If these 4 angles are placed in a bag, what is the probability of randomly selecting an acute angle? So on this one we have 1 acute angle, so out of 4, so that'd be 1/4. Any angle greater than 60, we have a right angle, an obtuse angle, and a straight angle, so that would be a total of 3. That's greater than 60, so 3 out of 4, 75%. On C, a right angle, there's only 1 right angle on there, so that would be A, and that would be 1 out of 4. And then an angle less than or equal to 180. Well, this one was a 90, this one's about 100, this one's 180, so it's equal to, and then less than as well. So that would be 4 out of 4, which would represent 100% or 1 as a decimal. Question 132. Examine the shapes below. We have A, B, C, and D. Describe what you know about each shape based on the information provided in the diagram. Then name the shape. So part A and figure A. What do we know? We know it has 4 sides, doesn't really have any markings or anything, so this would just represent a generic quadrilateral. So we got 4 sides. And then we'll just call it a generic quadrilateral. On to shape B. Now shape B has two pairs of equal sides, and so therefore that's a kite. So two pairs of equal sides. So that would be a kite. Figure C, we have four right angles and a pair of parallel sides, so it'll make it a rectangle. And then on D, we have four sides, so it's a quadrilateral, and it does have two parallel sides, so therefore it's a trapezoid. So that takes care of part A, and then part B. Let's see what it asks. Part B, decide where each shape would be placed in the Venn diagram below. So it has reflection symmetry, and then the other one has at least one pair of parallel sides. So on part A, it does not have its generic rectangle. It doesn't have reflection symmetry, and it also doesn't have at least one pair of parallel sides, so that's outside of it. On B, B has reflection symmetry, so you can reflect across that line. But it doesn't have any pair of parallel sides, so B would be over here. C, it has reflection symmetry in a couple different ways, but here's would be one. And then it has at least one pair of parallel sides. It actually has two, but at least one. So therefore it covers both of them, which means it's the intersection, so C would be in the middle. And then D has reflection symmetry. It does not have reflection symmetry, but it does have at least one pair of parallel sides, so it looks like D would go in the second one there. Question 133, solve each equation below and check your solution. So in part A, we're going to go ahead and combine the like terms on the left side. And then we'll get the variable term on one side and the constant on the other by using inverse operations. So add 2, divide by 5, x is equal to 2. And then it does say check your solution. Once again, remember that plug x equals 2 back into the original and evaluate and see if you get a true statement. B, we have x over 7 is equal to 3 over 2. So we can multiply both sides. You can do this in 2 steps or 1. I'll go ahead and do it in 2. If I multiply by 2, that's 2x over 7 is equal to 3 over 1. And then now we can multiply by 7. So to do it in one step, you could just multiply by 14. And then 3 times 7 is 21, divided by 2, and that's 21 halves, or 10.5. On part C, distributive property, 5 minus x minus 7 plus 4x is equal to 7x minus 7. Combine your like terms, so what do we get here? We get 3x minus 2 is equal to 7x minus 7. I'm going to subtract 7x. So what would that be? Negative 4x minus 2 equals negative 7. Add 2 to both sides. Negative 4x equals negative 5. Divide by negative 4. And x is equal to 5 over 4. And then the last one, D. We have x squared plus 11 is equal to 36. So we can subtract the 11. We're going to isolate the x squared. And that'll give you 25. And then you can take the square root of both sides, or you can just ask yourself what times itself squared gives you 25, and that would be 5 and negative 5. Otherwise, you get the absolute value of x is equal to 5. And then again, you get two solutions, x equals negative 5 or x equals 5. And you can plug those back in to check. Question 134, find the value of y for each equation twice. First for x equals 8, and then again for x equals negative 3. So in part A, we're looking at when x is equal to 8 first. So y is equal to 8 squared plus 13 times 8 plus 8. So this would be 64 plus, what would that be, 80 and 24, so 104 plus 8. That would be 168 plus 8. which is 176. So that's if x is equal to 8. If we do x is equal to negative 3, now we have y equals negative 3 squared plus 13 times negative 3 plus 8. Negative 3 squared is a positive 9 minus 39 plus 8. 9 minus 39 would be negative 30 plus 8. Negative 30 plus 8 would be negative 22. And so that's for x equals negative 3. Then we'll do part B, the same thing. We'll do when x is equal to 8 first. Y is equal to 6 times 8 minus 2. That'll be 48 minus 2, which is 46. So y is equal to 46 when x is 8. And then we'll do it again when x is equal to negative 3. So y is equal to 6 times negative 3 minus 2. That's negative 18 minus 2, or negative 20. Question 135. Graph and connect the points in the table below, then graph the equation in part B on the same set of axes. Also find the equation for the data in the table. So let's just start there by plotting these points. Negative 4, negative 5, negative 3, negative 3, negative 2, negative 1. Whoops. Try that one again. Negative 2, negative 1. Negative 1, 1. 0, 3. 1, 5. Hopefully you're starting to see what's going on. 2, 7. 3, 9. And then 4, 11. So you can see that is a line. Let's go ahead and connect them. And that's part A. That's from the table. So graph and connect the points in the table, which we did. Then graph the equation in part B. So let's go ahead and graph this equation. You could easily plug this into your calculator and look at your table to figure out what you're going to get. So I use the calculator to get the table. One thing you might notice is that negative 2 is the output for negative 1 and 0. So we know this is a parabola, therefore it is going to have a minimum value on this one. So it's going to go above or below the negative 2 just a little bit and then work its way back up. And so that will give us the graph. So we've done that. Now it says find the equation for the data in the table, which we can also do because it's linear. We noticed that it was increasing by 2 with a y-intercept of 3. So y is equal to 2x plus 3 for the table on in part A. In the last question, question 136, triangle ABC at right is equilateral. Use what you know about an equilateral triangle to write and solve an equation for x. If we know it's equilateral, then we know all the side lengths are equivalent. And so if that is the case, then 4x minus 3 should be equivalent to 2x plus 1. And we can solve this equation for x. And then that will allow us to plug it back in and see what the side lengths actually are if we need to. So 2x minus 3 is equal to 11. Add 3 to the other side to get 14. Divide by 2. And x is equal to 7. So 4 times 7 minus 3, that would be 28 minus 3 is 25. If I do the same thing on this one, I should get 25 also. 2 times 7 is 14. 14 plus 11 is also 25. So, I guess I go back and finish reading the question, but we did write and solve an equation for x, so we got that part done. Then it says find the perimeter. So now that we know all the sides are the same, 25 times 3 is equal to 75, so the perimeter would be 75 units.